Welcome back to the Dargslan series. This is part 4, and today is the day we stop talking about local AI and start preparing the machine that's going to run it. Think of this as setup day, Linux, GPU drivers, and Docker, installed once and verified properly. It's the least glamorous part of the journey, but everything from part 5 onward sits on top of what we build here, so we take our time and we test as we go. So here's the plan. 4 layers built from the bottom up. First, a proper Linux environment, Ubuntu 24.4, or WSL2 if you're on Windows, or just the macOS terminal. Then if you have an NVIDIA GPU, the drivers in CUDA, Mac users skip this since Metal is already built in. Next, the NVIDIA Container Toolkit, which lets Docker actually see your GPU, again, GPU only. And finally, Docker itself, the container runtime that'll host OpenWebUI, Chroma, and pretty much everything we add later. We install in that order and we verify each layer before touching the next one. So, 3 valid starting points. If you've got a dedicated machine, Ubuntu 24.04 is what the series defaults to. Native Linux, cleanest GPU story, every Docker feature works out of the box. On Windows, WSL2 with Ubuntu is genuinely solid. One WSL, install in PowerShell and NVIDIA pass-through just works. And on a Mac, you don't need Linux at all. The terminal is already Unix. Alma runs natively and Metal handles acceleration, so you'll skip the NVIDIA steps entirely. So let's actually get to a prompt. On native Ubuntu, run lsb release A and confirm you're on 24.04. That's our baseline for the rest of the series. On Windows, open PowerShell as administrator and run WSL, install dubuntu 24.040, reboot once, then launch Ubuntu from the Start menu, and on macOS, just open terminal.app. Uname should report Darwin, and that's your confirmation. 3 commands, 3 paths, same finish line. Now that you've got a prompt, the ritual is the same on all 3 paths. Refresh the package index and upgrade what's already installed. Then pull in the tools we'll lean on for the next 20 episodes, curl and wget for fetching things, git for cloning repos, build essential for anything we need to compile, the Python 3 trio, and 3 little quality-of-life utilities, htop, nvtop, and jq. Finish with Python 3 version on 24.04. You should see 3.12 something, and that's your green light. Quick fork in the road. If you're on a Mac, CPU only, or rocking an AMD card, sit this one out. AMD, folks. ROCm is its own adventure we'll touch later. For NVIDIA users, ask Ubuntu what it recommends with Ubuntu drivers devices, install whatever it flags as recommended, and reboot. Once you're back, nvidia-smi is the moment of truth. If it prints your card, driver, and a memory readout, the kernel and your GPU are officially on speaking terms. Here's what a healthy output looks like. You want 3 things: a driver version up top, a CUDA version next to it, and your card listed below with its full VRAM visible. 12 gigs on this RTX 3060, for example. If all 3 show up, the kernel sees the card, the driver's loaded, and CUDA is reachable. That's our green light to move up the stack. With the GPU verified, we move 1 layer up, Docker. Almost everything we run in this series, from OpenWebUI to Chroma, Qdrant, and N8N, lives in a container, so we want Docker installed cleanly once and then forgotten about. The convenient script handles Linux in 1 line. Then we add ourselves to the Docker group so we're not typing sudo for every command, and finish with hello world as a smoke test. If that prints its greeting, the demon's alive and we're done here. Now, Docker can talk to itself just fine, but by default it can't see your GPU, and that's where the NVIDIA Container Toolkit comes in. It's the bridge that lets containers reach through to the CUDA drivers we installed earlier. We add NVIDIA's repo, install the toolkit, tell it to register itself as a Docker runtime, and restart the daemon. Then the real test, spin up a CUDA container and run nvidia-smi inside it. If you see the same GPU table you saw on the host, the whole stack is wired up. Before we wrap up setup day, let's run 1 quick sanity pass. Walk down this checklist top to bottom, release, Python, Docker, the Hello World container, and if you've got an NVIDIA card, nvidia-smi on the host, and again inside a CUDA container. The last two are GPU only, so Mac and CPU only folks can skip them with a clear conscience. If everything comes back green, you're done. Anything red, circle back and fix it now. Part 5 assumes all of this works. And if something did come back red, odds are it's on this list. The big one, if nvidia-smi complains about NVML, you just forgot to reboot after the driver install, that one trips up almost everyone. Permission denied on Docker means you skip the user mod step. GPU invisible inside a container points at the NVIDIA Container Toolkit. WSL2 users, make sure both WSL, update, and your Windows side NVIDIA driver are current. And check DFH before you go any further. Models are big, and running out of disk halfway through a poll is a miserable way to spend an evening. Speaking of disk, let's make that concrete. A single quantized 8B model is around 5 gigs, the full precision version is closer to 16, the Open Web UI image adds another 2, and once you start collecting models, they pile up fast. Reserve 50 gigs as a floor, 100 if you can spare it. And on the network side, setup day is not the time to be tethered to your phone. The first pulls are heavy, several gigs of model weights, a few more for CUDA-based images, so park yourself on wired Ethernet or solid Wi-Fi before you kick things off. Before we install anything, let's give this whole series a home, one folder under your home directory, with subfolders for notes, scripts, docs, and Docker configs, and we'll get in at it right away, so every change from here on is tracked. Then drop a quick setup.md note recording your OS, GPU, CUDA version, and the rest. Future you debugging something weird in Part 17 will be very grateful. So, quick recap of setup day. 3 valid starting points, Ubuntu, WSL2, or macOS. Pick one and move on. Verify every layer before stacking the next. We test, we don't hope. Reboot after the NVIDIA driver or nothing else will work. Keep at least 50 gigs free, because models add up faster than you'd think. And put it all in one Git-tracked Workspace folder. That's the foundation. Everything from Part 5 onward builds on it. And to make that foundation easy to maintain, here's your cheat sheet. Print it, tape it next to your monitor, and when something breaks in Part 9 or Part 17, run through this list first. It'll catch 90% of issues before you even open a search tab. The left column is your install verification. The right column is the deeper checks. Python version, disk space, Docker, GPU pass-through, and the WSL kernel update for Windows folks. Most debugging sessions start and end right here. And that wraps Phase 1. 4 parts down, 20 to go, but the hard part is behind you. Next time, in Part 5, we cash in on all this setup. One command, one model, and you're chatting with a real LLM running entirely on your own machine. No cloud, no API key, no waiting. See you in 5 minutes.